Okay, welcome back to topic 4.2, net ionic equations. Before we actually go in on how to write an equation and a net ionic equation, I need to review a couple of things about the chemical equation with you guys, and then we're going to do some very quick review and practice with balancing chemical equations. So first thing to remember is to locate the yield arrow for any chemical equation, because that's going to separate the products and reactants. The right side of a chemical equation, let me start with the left. The left side of a chemical equation is always the reactant side, or the substances that will undergo a chemical change. The right side are the products, or the result of the chemical change. So you have your reactants on the left, products on the right. The numbers that appear in front of each substance in a chemical equation is known as the coefficient, and remember, coefficients are molar amounts. And if you do not see a coefficient in front of a number like over here, it's implied to be 1. So in essence, what this equation is saying is we have an implied 1 mole of C6H12O6 is reacting with 6 moles of oxygen to produce 6 moles of carbon dioxide and then 6 moles of water. The letters down here in parentheses are the states of matter. Okay, you guys should know that one already. G is for gas. L is for liquid. S is for solid. And a new one in AP Chemistry, we've discussed it already though, is AQ, which means aqueous, which means dissolved in water. Okay, so there are your different parts of a chemical equation. Alright, now let's go into balancing a chemical equation. We're not going to spend too much time on this because you should know how to balance a chemical equation by now. But remember, balancing chemical equations means you are holding true to the law of the conservation of mass, or the law of conservation of matter. Every chemical equation must have the same number of atoms on both sides. The quick and easy way to do this is to get an inventory of atoms on both sides. We have H's on the reactant sides and chlorines on the reactant side. And if we have H's and Cl's on one side, then that's going to be the same on the other side. Okay, so these are reactants and products. And now we're going to go through and count the number of atoms we have on each side. And again, I'm going to breeze through this because this is something you should already know how to do. All right, right now there's an implied 1 in front of this this H2 right here. So this 1 times this 2 means we have 2 hydrogens right now. And in front of this Cl, there's an implied 1 here, so 1 times this Cl2 means we have 2 chlorines. And there's a 1 in front of this HCl right here, so a 1 times this implied 1 with this H right here is 1, because that's 1 times 1. And then this implied 1 is also multiplied by this implied 1, the Cl. Remember, this 1 in front applies to both the H and the Cl. So there's 1 chlorine on that side. Alright, now we need to go through and make sure we have the same amount of atoms on both sides. Clearly we see that we can't, or that we don't, so we need to go back and change the coefficients in front so that we do. Okay? Well, let's start with the side that we have the least amount on, and that's going to be the product side, and we'll start with H. See that I have 1 H here. Okay? Now I need to get to 2. So what number can I throw in front of that HCl there? What number times 1 will get me 2? Well, it'll be 2. So if I put a 2 out in front, I'll have 2 times this implied 1 and that'll give me 2 H's on that side. That 2 is also attached to that Cl as well, so now I have 2 times this implied 1 down there with the Cl, so I have 2 chlorines. And as you can see, this equation is now balanced, okay? In regular chemistry, we would have had you gone through and put 1s in here. You don't do that in AP chemistry, okay? This is college level, that 1 is implied to be there. Alright, let's do something a little bit more complicated. Okay, we have aluminum phosphate reacting with sodium sulfide to produce aluminium sulfide or aluminum sulfide, and then sodium phosphate. So let's go ahead and go through and get an inventory of our atoms on both sides. We have an aluminum, a phosphate, an oxygen, a sodium, and a sulfide, all on the reactant side, which means I can just copy that list over here as well. Alright, let's count what we have on both sides. I've got 1 aluminum so far, 1 phosphorus, 4 oxygens, 2 sodiums, 1 sulfur. On the product side, I have 2 aluminums, 3 sulfurs. I only have 1 phosphorus on this side, okay? This 3 right here only applies to the Na, and this 4 right here only applies to the oxygen, okay? So there's only 1 phosphorus here. There are 3 sodiums, and there are 4 oxygens, okay? So let's go through and see what's balanced and what isn't, okay? Looks like the aluminums are balanced, the phosphoruses, or the aluminums are not balanced, the phosphoruses are balanced, the oxygens are balanced, the sodiums aren't, and nor the sulfurs, okay? So let's start with the aluminums, okay? I can see that I have 2 on the product side and 1 on the reactant. So I'm going to need to multiply this by 2, which means putting a 2 out here in front. But that also changes the phosphorus and the oxygen, because remember that coefficient out in front right here applies to everything. So now I have 2 phosphoruses, 8 oxygens. Okay, that's alright, we can go fix those later. Let's now balance the sodiums, okay? Actually, we're going to save the sodiums for later because I cannot easily make 2 into a 3. But let's try the sulfurs next, okay? Let's do the sulfurs. I have got 3 sulfurs on the product side and 1 sulfur on the reactant side. So I need to multiply this by 3, which means putting a 3 out here in front where that sulfur is, and that sodium sulfide. So this is 3. But guess what else I changed? I also changed the number of sodiums. Okay. This is now 6, because 3 times that 2 is 6. Again, you guys should be pretty well versed in the counting of atoms by now. Okay, now I can go through and try to take care of the sodiums. I've got 6 on the reactant side and only 3 on the product side. So I'm going to need to multiply this by 2 to get that to 6, which means coming up here and finding where my sodiums are and putting a 2 there. I now have 6. But look what else I changed. The phosphoruses and the oxygens. How many phosphoruses do I have now? Well, 2 times that 1 implied there means I now have 2 phosphoruses. 2 times this 4 means I now have 8 oxygens. And if I go through, let's see if everything is balanced. 3, 3, 6, 6, 8, 8, 2, 2, 2, 2. Everything looks good. And there's an implied 1 to be right here in front of the Al2S3, but we're not going to write that. Okay, last example with balancing chemical equations is the combustion reaction. Ladies and gents, combustion reactions involve taking a hydrocarbon, so anything with a C or an H in it, reacting it with oxygen to always produce CO2 and H2O. So every combustion reaction will have the same products. And on the reactant side, every combustion reaction will have an oxygen. The only thing that's really going to change is right here. We'll have a different arrangements of CHs and Os there. When you're doing a combustion reaction, ladies and gents, it's always a good idea to first balance the carbons, then balance the hydrogens, then take care of the oxygens using half coefficients if needed, and I'll show you what that looks like. Okay, so balance them in this order: first, second, third. Okay. Okay, on the reactant side I have carbon, hydrogen, and oxygen. That's all that's there, which means that's all that should be on the other side as well. Okay. So far I have 2 carbons, 2 hydrogens, 2 oxygens on the reactant side. On the product side I have 1 carbon, 1, 2, 3 oxygens. There's 2 oxygens here and then 1 over here, so that makes 3 total. And then 2 hydrogens. So the only thing that's balanced are the hydrogens. We need to take care of the carbons and oxygens, but remember, we're going to start with the carbons first, okay? I have 2 on the reactant side, 1 on the product side. So I'm going to multiply this by 2. Means I put a 2 out in front here. But I also changed the oxygens as well. I now have 2 times 4 oxygens, plus this extra 1 over here. 2 times 2 oxygens is 4, plus that 1 over there means a total of 5 oxygens. Okay. Next is to balance the hydrogens. Okay, well, the hydrogens are already balanced, so now let's move on to the oxygens. Okay, I have 5 on the products, 2 on the reactants, so I need to add to this side. Now, ladies and gents, you cannot very easily make 2 into a 5, okay? But we can multiply by a coefficient that will produce 5 on that side, okay? And here's how we can do that. If I multiply this by 5 over 2, okay, that means I will get 10 divided by 2, which is equal to 5. Okay, see what I did there? I have 2 there. If I multiply it by 5 halves, that'll give me 10 halves, which is equal to 5. So I'm going to put a 5 over 2 right here. Now, I'm going to go ahead and pause the video here, and in the next video I will go over what to do next.